application called densitydesign.org. It is a site that when you first see it looks very plain. It says insert your data or choose one of our samples. Now, while you were eating, I was preparing data so that way I wouldn't have to go through the boring process of showing you that thing here. So this is what I created while you were eating as I was sitting here. So I'm going to paste some of my pre-created data. This is randomly chosen XY coordinates. Okay, and then once you put in data, you see this, which is a bunch of different charts you can do. I'm going to test the Voronoi tessellation diagram. Line 2, size. I thought that looks good to me. Oh, that's really fascinating if that's a problem. What's line 2? It's saying that there's a problem parsing line 2. I wonder what that problem could possibly be. Is it because... it's because I had a blank line at the top. Wait a minute. It should be smart enough to know that blank lines at the top can just be ignored. Can you scrap that for me? Can you make a note of that for me so I don't have to write it down myself?
Yes.
All right. Look, I can just drag it here. Okay, that's good. And I'm going to leave color blank and see what happens. And, oh, there it is. It just automatically drew it. All right, now this is called a Voronoi diagram. Let me briefly explain what this diagram is. I love complexity. I love things that look cool, and this looks really cool. So anything inside this white border is closer to this dot than to this dot, or this dot, or this dot. So you could look at it as this is a bunch of McDonald's, and if your house is here, this is your closest McDonald's to you. You could look at it like that. What I'd like to do now is switch to some very patterned data, and I'm going to start with something very simple. Data have been successfully parsed. Okay, fine, we'll go with that. And then, it's making me drag onto the axis again. Wait, there's no reason, just because I replaced the data, that I should have to drag X to X and Y to Y again. It seems like it should know that, well, you wanted X to X and Y to Y. It should try to guess that I still want that. So that's something I want to complain about. And color, let's put color over here this time. And let's scroll down here. Oh, so this is just 5 dots in a diagonal, and you can see the Voronoi diagram is very simple here. This is called a simplified data oracle. With certain kinds of complex algorithms, if you give it really simple data, then you don't need anything fancy to tell if it's a bug or not. You just look at it and go, pretty obviously, these bands make sense. The kind of testing that I'm doing right now is what I call survey testing. Survey testing is dedicated to learning the product. The goal in survey testing is learn the product as fast as you possibly can. And to do that, we need to interact with the product, see what happens, and do what's called sense making. Another skill, sense making. Sense making is the ability to make sense of what happens. You look at something and you go, huh? And then you go, maybe that's why this happened. And then you do little experiments to confirm your sense making. So I made a spiral. And let's delete that, put in the spiral data. 174 spiral points. So what I'm trying to do now is select, by doing some different patterns, I'm getting a sense immediately, there we go, a little spiral. I'm getting a sense immediately of how well this thing handles lots of data points, extreme data points. So here I created a spiral that got larger and larger, and let me just do a sanity check. This is actually what I would call a spot check of the output. I am glancing at different places in the output to see if it makes sense. This is a weird one, so let me just check this, which is general systems thinking. General systems thinking is a name for a set of patterns and skills for taking any complex system and noticing patterns in it that allow you to break it down systematically and into simpler parts or simpler dimensions that you can then analyze.